Good morning, everyone, and welcome to this panel discussion on the AI embedded systems. So AI has become a cornerstone of modern innovation, and it is impacting our daily lives. In entertainment, it has taken content creation and interactive experiences to a whole new different level. It has become more engaging. In finance, there are different aspects which are being optimized, like trading. Yeah, it is also detecting frauds. In education sector, we are seeing more and more personalized learning, intelligent tutorial solutions, and so on. They are becoming more and more visible in the industry. But today we are here to talk about AI in embedded systems. What does it mean, AI in embedded systems? And how are different industries being impacted because of these things? So then I will hand it over to my colleagues here. So I would invite Mr. Mangesh to share some insights on the automotive side of this.
Thanks, Makarand. Very good morning to all of you. I think AI, I think all of us are already using AI, right? So whether it is in mobile to start with, and then in your home, in your office, and also when you drive to your work, it is there in your car. So I think AI is well taken care of. We already know about it. But we need to understand the AI, what we are currently experiencing. It is the AI models, what are there, those are huge models, no? That they will have billions of parameters running on the high power GPUs. No, but when we talk about embedded systems, as you all know, no, embedded system will be typically resource constrained. No? You will have, it has to take a real-time decision, and then it is also safety critical. So the AI in these kind of embedded systems is very different. I mean, you have to really customize it, make it I would say adopt it so that it fits into a embedded device. Now coming to automotive particularly, I think there are three mega trends in automotive. I think all of us know. The first is, of course, the autonomous driving. Then we have electrification as a second big trend. The third is the connectivity and digitalization. And the fourth buzzword what we have is the software-defined vehicles. I think in all these four mega trends, AI is going to play a very, very important role. And I think as we continue our discussion, we will unfold how AI will be getting into all these areas. But to just give you one quick example, let's take a case of an autonomous driving. What we do in autonomous driving, we have different sensors around the car. So we have LiDARs, we have radars, we have cameras, we have ultrasonic sensors, and all these sensors are going to create a perception of the around the vehicle. And this is getting used to do autonomous driving, maybe it will do a path planning. So multiple applications based on this data what you collect. And this is where I think AI is already playing a role, and it is going to play a very important role going onwards. The second example I will just give you is about the electric vehicles. I think all of us are now very much aware that these electric vehicles, they run on a lithium ion battery. And this is very safety critical, it needs to be monitored. Now all of that can really get enhanced. Safety can get enhanced, life can get enhanced, because you can have an AI algorithm which is built specifically for these kind of applications. So I think I see a tremendous opportunity when it comes to AI and when it comes to automotive. And automotive, I think has such a big application. It can really big opportunities going ahead. Thanks.
Thank you, Mangesh. So yeah, really very high potential to adopt AI into automotive systems. And then I would invite Mr. Hari Prasad to share some insights on the energy sector.
Good morning, everyone. So, like if you think about energy, right, first thing which comes in the mind is renewable energy, right? So, as you all are seeing, right, there is a lot of penetration of renewable energy. Now, when there is more penetration of renewable energy, obviously the challenge is energy management, protection, right, which is one of the key elements, and obviously asset maintenance or predictive maintenance, right? So these are the three areas where definitely we think about when there is renewable energy. Now, especially if I start with energy management, right? So obviously you need AI for forecasting. When I say forecasting, you want to understand how my loads are going to behave in next, like, tomorrow or in a month, in a year, right? So that you can do a effective planning, right? Now with more renewable, you have different sets of challenges, which means you need more intelligence, more better models, predictive models at edge level, so that you can predict different type of new faults which are going to come with more renewable penetration, right? Now the third element is more about asset maintenance. Like, for example, I have transformers, I have switch gears, right? I need to predict the failure ahead of time so that, I don't have more downtime, right? Which is actually going to create more problem for me. And to do this, obviously, I need better models. I need intelligence on my edge devices. I should be able to predict ahead of time, right? And that is where I see the applications of, AI embedded systems into this energy area. Thank you.
So great impact on the energy sector as well. And how about the industrial automation? Rushikesh?
Yeah, I think Mangesh and Hari, they already brought an aspect in terms of energy as well as an automotive. I probably get started with a fundamental thing about AI. When we talk about AI in embedded system, it's called as a EAI or embedded AI. Basically, it's nothing but like an integration of artificial intelligence with an algorithms like neural network, deep learning or machine learning into resource constrained devices, which may be made up of microcontrollers, sensor and IoT. And why it is important to really understand resource constraint, because that's where it's different than AI what we see into the cloud-based versus AI into the edge devices. Now, unless like an cloud AI, the embedded AI is something which has to take the decision locally, which Mangesh had already pointed out aptly. It's basically take a real-time decision without relying on any external server, without any connectivity. Now, what it actually means, there are three critical characteristics. One is on-device processing, which is basically in hardware, like maybe in variables, which has to process intelligence and take a decision. Then low latency, that's something crucial, right? Imagine you are undergoing a surgery, and then a particular equipment relying on to getting some intelligence from somewhere else and internet connectivity loss. Nobody at least I don't want it to be part of such surgery. So low latency is something crucial, and Shailesh should be probably talking more on that. And then energy efficiency is another aspect. We know most of the embedded system works on to the batteries, and most of AIs currently are very power hungry. That's where the data centers are getting flooded across the world, and for embedded, that's something exactly is contradictory. You cannot afford to have an AI which is consuming your battery, actually instead of that energy used for a right purpose. So with this background, I come from an industrial automation. So based on to my experience, what I believe that there is a vast use of AI in industry 4.0. We see almost like 50% reduction in downtime, 30% improvement into the cost saving or the cost avoidance. And as an India, as a country, we see a rapid need of an evaluation in agriculture and more about the mass production. We still rely on some external countries or foreign countries for the mass production or making it happen in terms of the large scale production. And I believe that the AI has some significant, massive opportunities to contribute there. And maybe a quick example, like let's say an agriculture where we see across the world water scarcity, and then companies like coming from an automation background, they can develop an AI-based solution which can offer a smart water irrigation, right? Or we can develop we have a temperature controller kind of where you can do a better infrastructure energy management. So we discuss and unfold many such topics. I think thanks Makarand for asking that question. So there is a real and good potential of AI into embedded system. Yeah.
Right, Rushikesh. I think you brought in very important aspects that what is AI doing to solve problems at the ground level. Yeah, this is a very important context. And then I would like to hand it over to Mr. Shailesh to talk to us about healthcare industry.
Sure. Good morning, everyone. So I work with Philips Healthcare. So in my talk, I'm going to bring more healthcare perspective how we are applying embedded AI. What does embedded AI means for me? It's basically chota package, bada dhamaka. So in a small hardware device, you can have enough computing power to run a AI ML model and which can give you a real-time feedback. Now imagine this, what power you have in your hand, and you apply that in healthcare, it gives a huge, huge opportunity to improve healthcare. How I define healthcare is across patient care journey or person care journey. The care journey starts from your wellness, prevention, diagnosis, treatment, and then home care. And in each of these steps, embedded AI can play a big role. I'll give few examples. Let's start from wellness. Imagine you're a smart oral healthcare device, a smart toothbrush. When you are brushing your tooth, it can predict, it can analyze how much pressure you are applying, how good you are brushing, and it can help you adapt so that you can have better oral hygiene powered by AI. Right there, improving your wellness day in, day out. If you move to prevention side, you have smart watches, sleep monitoring devices, and many more monitoring devices which can help identify if your health is deteriorating and create a quick alert for you. Further, if you go diagnosis side, AI-enabled portable ultrasound devices, which is run on a tablet and which doesn't require very high skill to operate because its AI is guiding how to use the overall ultrasound and still get a better image. And on the image, it gives the diagnostics findings as well. And when you go on treatment side, think about smart implantable devices like pacemaker, adaptable pacemakers, which adapts as per your body response and adjust your body parameters. So there are enormous potential and enormous activities already happening across over the patient care journey to apply this. And I'm really, really proud to work in this domain where our purpose is to improve people's lives. I'm really passionate about it through meaningful innovation. Yeah. So that's the view from my side.
Thank you, Shailesh. Yeah, on personal level, I would love to have a toothbrush which avoids a trip to the dentist. Yeah, so definitely a good thing. So now we have been talking a little bit about at a higher level that how AI is impacting different industries and so on. But what about India? Is there an Indian context to this? Yeah, is it helping us to transition into smart devices, smart technology? Is there some more untapped potential that we see here at the Indian level, which will help us to take things forward? So maybe Saurabh, would you like to add something on that?
Definitely. To start with, you said untapped potential. The way I see it, the AI itself is maturing and evolving. We have been in this industry, we have looked for machine learning a lot, okay? But traditionally, we have been only focusing on the functional use cases till now. I think there is a huge potential in the functional as well as non-functional use cases. Let's take an example of ADAS, which Mangesh mentioned earlier. We all of us know from last 2 decades, okay, that you can detect lanes, there are lane departure warning systems altogether. But if you look at the Indian context where there are no lanes, okay, this is where free space detection can play a role at lower speed. If I also look at BMS example, okay, there are standard algorithms available for Coulomb counting. But if you look at state of health, okay, that can be predicted better. So there is a huge use case in terms of functional side, in terms of prediction, not only, let's say, battery health, but also temperature sensing. If you look at, let's say, bigger mechatronic systems, you have an array of sensors, temperature sensors, whereas you can really homologate it, okay? You can triangulate it, and you can really predict the temperature within the vehicles. So there are many use cases, I would say. But this is only the R&D and the automotive part of it. I think there are also use cases on the plant side of it. We have talked about predictive maintenance. I think that's one of the big use cases. Digital twin, one of the big use cases, not only for the mechatronic system, but also for the plant. Right now, we are relying on conditional monitoring systems, which are highly prone to also errors. I think this is where AI can really speed up things for us. So I would like to say that it is not only about functional and non-functional, it also about players. In the Indian market right now, if we look at Pune, okay, it is the automotive hub for India, I would say. And it has given new opportunities to the local suppliers, players, okay, because now the ground is not flat anymore. That, okay, there are only one or two players that can stand alone. I think this opportunity, if we are able to grab it, okay, things can change for sure. Okay.
So thanks, Saurabh. I mean, talking about predictive maintenance here, or predictive diagnostics. So who wouldn't love to have a car which can predict that it is going to break down in some time, yeah? So that you can avoid mid-road inconveniences, yeah? So that is definitely something very useful. So thank you, Saurabh. So Milind, how about railways? Yeah, India has a very big railway industry. How do you see railways?
Yeah, I mean, of course, I come from a railway industry which is quite closer to automotive, I would say, not completely, but definitely railway is evolving all over the world, not just in India. So I'll put it little more in the perspective that, you know, the competence center, the global centers which we are having in India, I think the India is going to be center of attraction for all these setups. And in the past, if you recall, it was a cost arbitrage wherein it was considered India as a work package country or the service-oriented country, but now it is no more a true story. Everybody is looking at a lot of efficiency-related measures, a lot of competence-related measures, and AI is going to play a major or crucial role in this particular area. But when I say AI is going to play, AI is a big word, or I would call it as a big buzzword, I would say. We have to break it down into multiple sections, multiple areas, and we have to really understand how this is applicable to your own industry, how this is going to improve your own efficiency measures and so on. So with that, when I talk about railway industry, I think in railway, driving from one location to the other location was more than enough so far. But we are talking about now a lot of the digital connectivity, the preventive maintenance topics, the conditional based maintenance topics. And I don't know how many of you know that in railway industry, the product life cycle is more than 20 years. And if we talk about that, AI is going to play a major role here because stopping a train into a garage or maintaining it is not really a viable solution for our car manufacturers or the customers. And they are going to ask for really innovative solutions. How can I predict my maintenance? How can I have a more availability of train in future and so on? So coming back to Indian industry, I mean, if I talk about technology centers, this is going to be a important or core part for our industry, Indian industry, because I can share one of the examples. Our CEO was visiting Pune, and he took a name of Mr. Modi, saying that Modi implemented UPI, I mean digitalization in such a high scale, which no other country is able to do it. So why not AI also starts from India and tell global that we are not just a service-based organization, but we are also competence centers. So I would say it is going to be a very crucial in future coming next 5 years and so. So thank you, Makarand, for that question.
Thank you, Milind. I think this is also very important. So it is not anymore only about the costs. Yeah, it is also about comfort and convenience. So India is changing, the lifestyle of people is changing, what they need from the society, from such public services, this is changing. Yeah? So this is really an opportunity for us to integrate AI into all these systems. And then coming back to healthcare, again, India, healthcare, this is a very sensitive topic. So how do you see healthcare into this?
Yeah. Certainly, we see huge opportunity where AI in Indian context can play a big role. Yeah. If I look at what is the current problem in the healthcare ecosystem, it's quite burdened. Just to give you stats, we have only one doctor every 850 people. And if you go to rural areas, this ratio is worst. So access to care and affordable care is a big, big problem. And that's where India can step up using embedded and AI and digital connectivity to really revolutionize this. What is important? India is always pioneer in frugal engineering. We have a lot of great talents in embedded, in AI. We have huge potential. They can develop cost-effective solutions. And of course, embedded AI helps us enable, as I mentioned, that in a small package, you have quite power in your hand. It can help me develop smart diagnosis and smart monitoring devices, which could be very cost-effective and increase access to care. India can revolutionize with this help, primary healthcare. We can reach out with these smart devices to all the rural areas, and we can improve home care for our elderly and for chronic disease people. We can have smart devices there like fall detection, like medication monitoring and many monitoring devices, right? Which can help improve the home care. And if you can keep going, we can make screening very affordable, like regular diseases like tuberculosis, diabetes. We can really democratize these at very affordable cost by having these kind of smart devices across. So India can really lead and make a big impact, not only to India, to global world here. Yeah.
Right. I think it is also important to see that now a lot of smart devices are coming in, starting right from smartwatches and so on. So all this is part of healthcare, I believe. Finally, you are able to monitor where your health is going, how it is impacting, and bringing in AI into these topics, it can very easily probably predict such predictive diagnostics we are talking about again. So that would be really helpful. And then maybe Rushikesh, if you could add something on the industrial automation side.
Yeah, I mean, the way Shailesh and Milind mentioned, when we talk about an Indian context, it doesn't only mean for an Indian consumers. I mean, we have an opportunity to create a global impact sitting in India, and that's what the Global Capacity Center or Capability Center means. When it comes to an industrial automation, I think our government is driving in a big way for Make in India initiative, and that's what something for a mass scale production is important. And a buzzword again, you all must have heard about and smart manufacturing. So implementing embedded AI into manufacturing probably help in preventing the accidents. And then we can reduce the downtime of our machines, which ultimately help in increasing the production, cutting down the cost or the stages which are required in the production environment, ultimately increasing your efficiency, productivity, quality, and leading to a lot much affordable solution to an end customer, be it into agricultural, be it into building automation, industrial automation. Other aspect which is very critical for an India is on digital transformation. One example, what Milind took was an UPI. I mean, the kind of such scale of operation, if you visit in Europe or US, you will not have such kind of an accessibility for a payment. But apart from the banking system, there are many areas where digital transformation is reaching to a multiple end points, and AI plays a very important role. So other than smart manufacturing, I could see the smart cities where intelligent traffic management or intelligent waste management or efficient energy management, I think that's where AI can play a role, and like an automation, the products from industrial automation can add a lot of value there. Maybe some of the monitoring relays which monitor voltage, current insulation, and then proactively inform, maybe a timing based controls or the PLC and HMIs which offers some kind of an ease of use to an end customer. And the last but very important, which is impacting irrespective of industry to all of us, it's consumer IoT, right? Then it could be a wearable or simple the voice assistant where you just give a command and then It brings you an ace of life. Your fan lights can get turned on and turn off. So yeah, I see a huge untapped potential as well as limitless opportunities in all the sectors what we touch base.
True. I think increasing the smart manufacturing, so it increases the productivity and finally it brings down the costs, which impacts every one of us. Mangesh, would you like to add how it impacts the last person? Yeah.
Yeah, so I think one area which we haven't talked about so far is agriculture. No, India is an agriculture economy, and I was recently reviewing some projects which different researchers are working, and I think they have immense potential to incorporate AI and in an embedded environment. Because agricultural, first thing we have this, all these are remote areas where the fields are located. And it is possible because of the technology, IoT technology, what we have developed to really monitor the soil, to monitor all other environmental parameters. And then it is possible for a farmer to take a photograph on his mobile and then get a recommendation of what kind of fertilizer he has to use, what kind of insecticide he can use, in what quantity he can use. All this is really, it will transform the way the agriculture is we do. And I think this is very India specific thing, right? And it has a big impact.
Right. Yeah, I think this is a very important aspect. So we are all sitting here talking about this, but 70 to 80% of our country is still having their income based on agriculture. So bringing in changes in agriculture industry, that is also very, very important. Thank you very much, Mangesh, for that. Now let's come to what AI means for individual organizations. Is it really saving some efforts? Is it bringing down the time to market? Or is there a marginal increment in this direction? Or is this really a paradigm shift? How do you see this? Again, Mangesh, if you
Yeah,
like to
thanks,
start.
Makarand. I think when talking about automotive, first thing, Makarand, it is certainly a paradigm shift. No, if you see the automotive development process, it is a long process. If you want to develop a new car line, it takes 5 years. No, and I have seen that. No, it is huge amount of development teams which are involved. A lot of testing has to be done. So this entire cycle of the development, in terms of processes, starting from the requirements gathering, then you do design and development, and then testing. All these three areas are really transforming because of AI. So to give you some example, like requirements gathering. Usually when we get a project from an OEM, they will share a huge bunch of documents. Say, okay, these are our requirements. Because, vehicle is that complicated. Now for a developer, when we develop an ECU, it is a huge task to analyze all those requirements, to make sure that there are no contradicting requirements. Now all this is now very, I would say, much easily done with the large language models what we have. And I think this is for the requirements. But when it comes to design and development, I think that's where we need to really look from an embedded system. I see it in two ways. For an embedded system, I think many of you are working in that area. The first is about the controls part of it. All embedded system will have some kind of control, whether it is open loop, closed loop control. And now how is it changing with AI? These are safety critical. So naturally the AI will not replace the traditional control. But then AI can augment that control. So this is really the AI getting into the control part of it. Like, I think you may know about model predictive control, because in a control, usually you need to model a system. And if you know your system very well, then of course you can control it very well. Now this part is where AI is very good at it. And I think we have really good ways of improving the control part of it. Then the second is about the design process. As I told you, that automotive is very much safety critical, and there is a lot of testing. So we start with at least 10 levels of testing. We start with unit testing, system testing, integration testing. Now all kinds of tests we have to do. Hardware in loop, mill, seal, hill. Now all of these, first thing is that they need the model of the vehicle. Now the biggest change I would say in this whole development cycle is about creating a virtual development environment. And once you create this virtual development environment, then everything becomes very different. And that's what is a paradigm shift. No, rather than depending that I have to go on a vehicle. I mean, when I started my career, everything you make a change in algorithm, you go on a vehicle, no, and then try to test it. Now that all is going to change. It has already changed, I would say, to a large extent. So, and then I think, yeah, all areas within the development life cycle are going to affect.
Right.
Right.
That is absolutely true. So it is, all the organizations are using the large language models. They are creating some kind of wrappers within their domain. So their domain expertise is retained while using the intelligence from the outside world to make things faster. Saurabh, would you agree with these things?
I think on most of the topic we share the same experience altogether. I see also, let's say, some additional challenges. I firmly believe that not everything that AI does is perfect. Okay, you should know how to control it, and there are few different players who are really winning in it. For example, there are a company called as RackIron. Okay, they have really come up with a very intelligent way of doing requirement engineering. They have come up with a metadata format, which is requirement interface. They are able to generate requirements, test cases, and also traceability for it. And they are able to adapt to any of the ALM tool chain, whether you're working with Polarian, with PTC, CodeBeamer, different tool chains. So this is where I see, still we are using human in loop approach for all of this smart engineering initiatives. Most of the organizations are specifically using it in copilot mode. I would say everybody is aware about the agentic mode. I'm really curious to see the next evolution where all of these agents are able to interact with each other. I think this is where the real efficiency would come out into picture. So that's the natural evolution I see for AI in embedded.
Correct. So cross-domain integration is the key, right? So Milind, would you like to add something?
Yeah, definitely. As I said in my previous answer also, AI is a big word, and you have to really break it down to the below level, how you want to make it apply to your own product range and so on. In general, cloud-based AI, I would call it as a general AI, but when it comes to embedded, I do not want to call it as a simple AI, but I would like to break it down kind of edge AI or edge computing AI because of our embedded world. Here basically organizations needs to be very careful when they are taking or adapting to the AI related topics. Because if we take our traditional V model, where we always, focus on the right hand side of the V model, wherein we are trying to automate testing, a lot of testing and so on. But when it comes to safety critical products, nobody is at least trying to touch the left hand side of the V model, wherein the development is involved. And there basically we still have those the hesitations or the doubts, especially for the safety critical systems. And one point I would like to mention, because efficiency or time saving is not just from the development or testing. If you know the certifications, these TUV certifications, the enormous documentation involved in these processes, people take almost the same development life cycle for the documentation also. So there I see a very big benefits when it comes to, and you know that as engineers, we are always lazy to do some documentation. So I think my take on this is we are still in that KG standard when it comes to applying AI for the development side. But for the testing side, yes, we have progressed well. And it is showing some results of efficiency. But I would say we don't want to conclude it right away. It will definitely have potentials to save our development life cycle. But considering the different domains, industries, I think it will differ time to time. So that's take on me.
Right. So thank you, Milind. I think automating these routine and administrative tasks, yeah, the documentation part of it, but with intelligence. So that is the core part of AI. Thank you. Hari Prasad, how about you?
I think my colleagues already covered well for this answer, but I think I'll highlight 2 points. One is these models need, in order to build these models, obviously there is a training phase, right? So obviously training phase needs a lot of data, a lot of experience, a lot of data. So that is one element which we need to be aware of, and it takes considerable amount of time to build models, to train them. That is one element. But second thing is the outcomes of the model, right? Are they right? Are they wrong? The ability to predict, the ability to understand that is very important. And to do that, actually, one thing which is very important is the deep domain knowledge. Deep domain knowledge plus AI is very important. I mean, if you segregate both of them, the deep domain knowledge without AI and AI without domain knowledge doesn't make sense. So that's where you need to have both. Then only you will be able to actually understand whether my model is actually giving good outcome or not. And in the training phase also, it's very important that I'm able to put right things in my model so that it makes sense, right?
Absolutely correct. Yeah. So the same thing. It's very easy to automate routine administrative tasks, but bringing in domain knowledge is the key. So the faster we are able to do it, faster we can actually reduce the development and time to market timelines. Yeah? So we have been talking all about the good things of AI, what all things it can do. Yeah, it's so nice and good to have AI. Yeah? But I'm sure there must be some challenges. Yeah? It might not be a cakewalk to integrate AI into our day-to-day lives. So Shailesh, how do you see integrating AI into healthcare? Yeah? Are there any challenges?
Yeah. So I think there are many challenges on the way. Some of the colleagues already mentioned earlier. But I will still cover few things, starting from data collection itself. In healthcare, data is so fragmented. How do you collect that data, create a meaningful structure out of it for modeling your AI models? Then we talked about embedded AI. Of course, I have limited processing power there. I cannot run big models there. So I need to decide a trade-off of optimization of speed versus accuracy, and that impacts my healthcare outcomes, what I'm going to analyze there. And it also leads to quite a lot development complexities when we develop that. Healthcare is quite regulated industry, so a few more challenges are there, especially related to data privacy, cybersecurity. Imagine you have AI models running on your systems and somebody hacked it and tamper your data. It can really cost someone's life. So data security and cybersecurity is quite important. And even getting regulatory approvals. There's no standard framework available as of today. And it's quite challenging. So what we do is we have to proactively work with regulatory bodies like FDA in India, CDSCO, to proactively work with them to get these approvals. And eventually things are improving. And I'm quite positive there is solution for each of these challenges. And over a period of time, working with the right partners, right companies, they help us solve these problems. So that's what my take is. I'm quite a lot dreamer. I see AI is going to enable better care for more people. It's going to give us, all of us, very personalized care. And future of healthcare will be really smart, connected healthcare there.
Thank you, Shailesh. Yeah. So as they say, garbage in, garbage out. Yeah. So quality of input data is most important, even if it is AI. Rushikesh, how about the industrial automation side of it?
I'll start with what Shailesh mentioned. I mean, you need to be hopeful and dream big. So I am of same opinion. I believe that AI can influence our lives, including health care, maybe consumer, industrial, and automotive. We were just discussing about what are those tools available, right? And we know probably when we talk about the PCB routing, the auto layout is being available, or the auto coding is available, Copilot is now enabling, and probably next generation engineer are using it very wisely. I did came across one of the tool called Circuit Mind, and probably another one is a circuit tree, where you draw the block diagram, take up a snap of it, and it will generate the schematic. So definitely it generates generate a value in saving development time. However, the real challenge comes when I looked about an AI in embedded or overall. I see a lack of hardware ecosystem available in India. Today, we still depends on getting cheap imported. That leads to a increase in cost of a product. And if you are going to give an additional feature, but with a significant increase in cost, probably at least in Indian market, nobody is going to really go over it. Like Indian consumers are cost sensitive. They want a quality product, but at an affordable cost. So I see that as one of the challenge. Second, the skill gap. I know we are talking and sitting today in Pune, it's being a hub for an embedded engineers. But when it comes to a potential of a knowledge available with embedded AI and IoT, I think we are short of it. It's something can be handled and there are being industry, academia collaboration happening and that can take care of it. A significant risk I see in terms of a cyber security risk. Now, whenever you get an opportunity to connect externally, whenever you put anything into a firmware, I think that's going to lead to a potential opportunity of hacking, and the regulatory frameworks are still evolving. And I believe that government and the private companies has to collaborate here, share knowledge with each other, and as a country we need to come across or come up with a very strong regulatory framework for cyber security aspect. Then AI also, the way it poses a lot of benefit, it also raises a risk of getting branded. And what I really mean that if somebody is just using as a prompt engineering and getting that output, I think that's not what engineers on the innovation means, right? You need to still apply your mind. Maybe some of the administrative tasks can be given to AI, but the real problem solving innovation, that still has to happen in through an human intervention. And the last and very important, I think Shailesh touched that initially. Whenever we wanted to really integrate AI into embedded, you really need to optimize the AI model. They are power hungry, they are processing, they need a lot of processing power, they are memory hungry, and all of these are constrained in AI. So all in all, I would say that it's a good start. We are already seeing few things getting positively impacted, but there are challenges. I believe that those we are in position to overcome them and looking forward for a very bright future of AI in embedded.
Mangesh, would you like to add?
I think Rushikesh has covered most of the problems which are again common for automotive. But in my experience, what I have seen in last couple of years working on developing the AI solution, the first thing is about data. No, so it is the quality of data is the biggest concern. Then you have to to train the model, you have to annotate the data. No, you have to create a ground truth for the model to know, which is again very time consuming. And the third thing is that the whole development needs a different skill set. I mean, you have a data engineer who can just look at the numbers or the data, but he will not be able to see what data is not correct. No, so that's where I think we earlier mentioned about having a good domain understanding how it functions. So that part is, I think, very critical to understand what is good data and what is not good data. Otherwise, your models are going to be very different. And then the other thing I see is that it will never be an AI and only AI, no, when it comes to embedded. Because, traditionally we have been using the physics-based control or physics-based system. No, we understand, and suddenly we say now, no, you do it only with data. So that's not going to work. So you will have to find a midway, how the AI will get in. And this is challenging. This needs the complete retraining, reskilling of our people. And I see it like for those in automotive, they can realize that, we had this auto code generation when it started. It suddenly changed the scope for a software developer. He is no more a software developer. He has to build a model. And then everything is changed. So I think in AI also that is going to happen. That the AI models are very standard. I don't think automotive or any of the embedded application will need a very sophisticated AI model that we are used to when you run it on the cloud. So the systems will be simpler, but then how to integrate them, how to find that balance is where we have to train our engineers. They need to be more system oriented rather than only particular software or hardware. Because AI is ultimately a combination. So AI will be effective only when we have all these things coming together and working really harmoniously. So whether it is a hardware optimization, whether it is a software optimization, no energy optimization, all these will have to come together. So that's what I see the big challenges. There are of course many other things. So it is going to be a interesting journey and with a big impact. But also we have to really do lot many things to make it happen. Thanks, Makarand.
So Milind, would you like to add your views?
Yeah, I think my colleagues have almost covered everything, but I would like to bring in a different perspective here from the railway industry specifically, because our life cycle is really pretty big and long. I'm thinking from the certifying body perspective, because our products are safety critical. In fact, in rail industry, we have to follow the safety integrity levels 4. That is the highest level of safety integrity. So there basically how the certifying bodies are reacting, because when we are doing our normal safety critical product development, they are also certifying the debuggers and compilers for that matter. But when I say them that now we are going to use AI, how are they going to certify, how they are going to look at that development domain or the area. So that is going to be interesting. We are still working on that. I do not have an answer today. But definitely it is going to evolve over the years, and we will have some solutions. But my guess on this AI topic is basically it is going to be a crucial and critical part of our development life cycle, and it will have prominent future in the industry. Thank you.
So thank you, Milind. And that also brings us to the end of our discussion. It was very insightful, at least for me. I learned a lot from everyone here. I'm sure the audience also would have understood a thing or two more. Yeah, it is interesting to understand that AI has huge potential, not just at a global scale, but also at Indian scale. We are also doing a lot of things at agricultural level, yeah, and not just at a high technology level. We have a lot of challenges, input data being one of the things, and finally the human aspect of it, yeah. So that is still very important, very significant. While we are training and learning the models and everything, the feedback and the correction loops, these will also go on. But this is all the part of change which is coming. And it is not far, it is here already. It is just about accepting the change and learning to use it to our advantage. With that, I would like to conclude this discussion. So thank you very much, everyone. Thank you, audience, for this.
Thank you.
And I think we have questions.
Yeah. So in case there are any questions, we can take them. 1 or 2, yeah. A mic will be passed to you.
Hi, this is Dr. Sambhaji from OSS. And this question goes to Shailesh directly, which is related to the healthcare. But it's not related to the hospitals and all kind of things, operations and those things. My question is direct to the natural resources which are really consumed by the human beings. Okay, so what are the measures been taken for such kind of resources, okay, which can be detected earlier with the AI, the algorithms and modeling, okay, as we seen few newses which are coming like people are losing their hairs, or sometimes now they are losing their nails and all these things, okay. So Shailesh, please.
Yeah, as I mentioned, on the wellness and prevention side, there's a lot of scope where we don't need any healthcare expert, right? And in day-to-day life, these smart sensors can help us identify any regular deterioration happening in our life, on our body as well. Just to give one example, there are sensors now. You just, on your phone, you on the camera, and you just put your finger on that, on the camera. It actually analyzes the overall blood flow, and it can predict how your heart is working, and it can give you analytics of multiple health parameters right away. So there is an enormous potential where you don't need to be a healthcare expert, and with the help of these smart devices, you can proactively monitor your own health and really take care of yourself. And so I hope that addresses your question.
No, my question is about the analysis of the natural resources, where the human beings are just live things, they are interface. For example, it could be animals, cows, okay, and most of us are drinking water, isn't it, which is available from the remote resources. Okay. So is there any kind of AI systems plan to analyze those kind of resources and those?
Yeah, actually, I'm sure there are. I am not aware. Maybe somebody wants to address that. You want to address, Saurabh?
Maybe I just add one point to if I understood your questions correctly. So if you talk about the water, what we drink, all of us have this water filter at home, which will tell you what is the TDS and other things. It is already having sensors in it. So what I see is that eventually, as the home gets more automated, if you take only for a drinking water perspective, already you will collect a lot of data of the incoming water and the water what you are drinking. And eventually it will, the model can tell you because the devices are connected. So this data will go there, yeah.
Are really these bottled waters, okay, they are again, finally they are coming from the natural resources, isn't it? Okay, so are there any plannings or AI can be implemented in that kind of natural resources? Okay, so it will give us kind of informations and those things. Okay, automating the water filters or ROs and all these kind of things in houses. It's already there, but how hazardous they are there? Okay, because we are mixing the more chemicals and how we are diluting, how we are making them, hazardous for the human bodies and those things. Right. So this has to be taken care at the basic level, okay, of the natural resources. That's
right. I think this is a very important aspect which you brought in. So to be honest, I am not aware if there are already such applications which are there or not, but we talked a little bit about the agriculture industry, and we are also trying to bring in AI. We are also trying to bring in AI into the agriculture industry. So I'm sure there is a lot of potential that when the irrigation is happening, it is also checking what is the soil quality, what are the nutrients which are going into the plants and so on. And that is what is finally what we are consuming. So I'm sure there is a lot of potential over there. It could be an untapped potential, but definitely possible.
Makarand, just to add, I can point you in a direction. There is a company called Art Ion, which is working on negative ion generators. These negative ion generators are very important for increasing the fruit yield and fruit drop rate. Okay, I'm pretty sure there are many companies such which are working in this direction where they are focusing on such topics. Right now, whether they are connected to the AI solutions, embedded for sure, AI, I'm not aware of.
So,
Saurabh, just a minute. For knowledge of Saurabh and all of us, actually, we are the oasis. We are taking care of those things to analyze our natural resources at the Gram Panchayat level also, village levels and those things. This is our initiative, actually. So,
I think government of India recently has announced this soil card. No, and then there is Ayushman Bharat where you make an health card. No, these are what? I mean, these are the wallets where you collect all the data. So it will keep on collecting the data of a soil, for example. And then after some time, it cannot happen all of a sudden. After a few years, when we have all those sensors,
we
will definitely
implementing it.
Correct.
Great.
Yeah, hi. This is Dr. Anand here from Millennium Semiconductors. This question is to Mr. Milind. And you've been, I think most of the people are addressing that, like any of the product which is there, you definitely need to have an domain knowledge. At the end of the day, domain and functional, both, it has to play a very important role. When I mention on this, there is a design verification, validation, there is also pre-compliance, compliance, and certifications. As we see, there are some areas we are matured, There are some areas we are not matured enough. But the question is that how this AI is going to be, I'm only targeting specifically with respect to the verification, validation, and certification. So because our regulatory systems are not that matured enough as we say about, like, when we compare this with Europe and American countries, in India, regulatory systems are building up. But when we mention onto that, like, how do you think, and which all the organizations, if you can able to mention, on the verification and validation perspective, the AI organization has been working on, and how to implement. There are definitely, because when we mention on this, it's a very broader problem statement. And when we talk about specifically onto the automotive or medical or aviation or defense, it has its own kind of, because every domain and a function is completely different, and their regulatory systems are different. But how this is going to, AI is going to, how do you think that? Because this is where something which I always see as a blank or a gray area. What is your comment on this?
So I mean, on the verification and validation, as I said clearly, I think the focus is very, very clear there, because as I told you, on the development side, we still are not there, and we are not trying to implement those complex algorithms with AI. But on the verification and validation, I think there are a lot of possibilities, right from the test coverage of the system and until the validation of it, and then creating a documentation. Because as you know that in safety critical systems, we have a lot of stages of testing itself. But I still say that we can do it up to certain level, not completely. And the last phase, which is like kind of an acceptance test or whatever, validation step, that has to be still done as a system, by a system engineer. So I would say today we are trying to use Microsoft Copilot. I can give an example, wherein we are trying to create those test cases automatically, trying to test it and so on. We have not yet completely done there. We are still evolving it. And if we talk about efficiency point of view, there is a potential. We are able to see that potential. But to answer now your question, that we are targeting on the verification and validation, but not 100%. I would say it is, we are around 60 to 70%, wherein we are trying to create those cases and do this. But still, the gray area remains is your certification body, how they look at it, because they are always interested in the right-hand side of the V model, and how they take it forward. That's the interesting story which we have not yet initiated, I mean. So that is what I can answer.
Thank you.